frame of a mobile home can be considered the grounding electrode system, which provides a path to ground fault current. However, it is important to note that it is not always directly connected to the power company's grounding electrode. Most electricians recommend bonding the mobile home frame to the power company's grounding electrode for safety reasons. This ensures that all conductive surfaces in the home are at the same electrical potential, reducing the risk of electrical shocks. Some individuals may argue that bonding the frame to the power company's ground creates a parallel path for lightning strikes, increasing the risk of damage to the home. However, this is generally considered theoretical and unlikely to occur in most cases. Benefits of bonding the frame include improved electrical safety for occupants, reduced risk of electrical shocks, and conformance to electrical codes in many areas. Disadvantages of bonding the frame include potential for increased lightning strike damage, although this is highly unlikely and it may require additional materials and labor. It is generally recommended to bond the mobile home frame to the power company's grounding electrode based on the opinions of most electricians and the safety benefits. It is important to consult with the qualified electrician to ensure proper installation. A grounding electrode system is a critical component of an electrical system designed to provide a low impedance path for fault current to return to the source. This path is essential for the proper operation of overcurrent protection devices, such as circuit breakers and fuses, which are designed to interrupt the flow of electricity in the event of a fault. Without an effective grounding system, fault currents may not be able to quickly return to the source, which can lead to prolonged exposure to dangerous voltage levels and an increased risk of electrical shock or fire. Grounding electrode systems typically consist of one or more grounding electrodes that are connected to the electrical system through a grounding conductor. Grounding electrodes can take many forms, including ground rods, ground plates, metal underground water pipes, and concrete encased electrodes, also known as UFO-grounds. The selection of the appropriate grounding electrode depends on a variety of factors, including soil conditions, local building codes, and the size and type of electrical system being grounded. The grounding conductor is a conductor that connects the grounding electrode to the electrical system. The size of the grounding conductor must be appropriate for the size of the electrical system, as specified in the National Electrical Code, or NEC. The NEC provides detailed requirements for the installation of grounding electrode systems, including the size and type of grounding electrodes, the size of the grounding conductor, and the methods for connecting the grounding electrode to the electrical system. These requirements are designed to ensure that the grounding system is effective and safe. In the context of a mobile home, the metal frame can serve as a grounding electrode. This is because the frame is typically in contact with the earth, which provides a path for fault current to return to the source. However, it is important to note that the effectiveness of the frame as a grounding electrode depends on a variety of factors, including the size and type of frame, the soil conditions, and the presence of any insulating materials between the frame and the earth. Bonding refers to the process of connecting together all metal parts of an electrical system that are likely to become energized. This includes metal enclosures, metal conduit, metal water pipes, and the metal frames of appliances and equipment. Bonding is essential for electrical safety because it ensures that all conductive surfaces are at the same electrical potential. This minimizes the risk of electrical shock if a person comes into contact with two different metal surfaces that are at different voltage levels. The NEC requires that all metal parts of an electrical system be bonded together. The bonding conductor must be sized appropriately for the size of the electrical system, as specified in the NEC. In the context of a mobile home, it is important to bond the metal frame to the electrical system. This can be accomplished by connecting a bonding conductor from the frame to the main grounding busbar in the electrical panel. This ensures that the frame is at the same electrical potential as the rest of the electrical system, which minimizes the risk of electrical shock. The power company's grounding electrode is typically a ground rod or ground plate that is installed at the service entrance of a building. This grounding electrode is connected to the neutral conductor of the power company's electrical system. The purpose of the power company's grounding electrode is to provide a path for fault current to return to the source in the event of a ground fault on the power company's system. Connecting the mobile home frame to the power company's grounding electrode can provide additional safety benefits. This connection creates a redundant grounding path, which can help to ensure the fault currents are quickly and safely returned to the source. However, it is important to note that this connection can also create a parallel path for lightning strikes. A parallel path for lightning strikes can increase the risk of damage to the home because lightning current can flow through the electrical system, which can damage sensitive electronic equipment. For this reason, some people argue against connecting the mobile home frame to the power company's grounding electrode. However, this is generally considered a theoretical risk and is unlikely to occur in most cases. The benefits of connecting the mobile home frame to the power company's grounding electrode typically outweigh the risks. Improved electrical safety for occupants is a significant advantage. Bonding the frame helps ensure all conductive surfaces are at the same electrical potential, reducing the risk of electric shock. Another benefit is reduced risk of electrical shocks. By providing a lower impedance path for fault current, bonding helps to quickly trip circuit breakers or fuses in the event of a fault, minimizing the duration of exposure to dangerous voltage levels. Conformance to electrical codes in many areas is another important consideration. Many local electrical codes require bonding the mobile home frame to the power company's grounding electrode to ensure electrical safety. A potential disadvantage of bonding the frame is the possibility for increased lightning strike damage. Although highly unlikely, some argue that bonding creates a parallel path for lightning, potentially increasing the risk of damage to electronic equipment. This is a theoretical concern and not a common occurrence. Another disadvantage is that it may require additional materials and labor. Connecting the frame to the power company's grounding electrode may require additional grounding rods, conductors, and labor, increasing the overall cost of the electrical installation. In conclusion, it is generally recommended to bond the mobile home frame to the power company's grounding electrode due to the safety benefits and code compliance. However, it is important to consult with a qualified electrician to ensure proper installation and to address any specific concerns related to lightning protection. An electrician can assess the specific circumstances of the mobile home and provide recommendations based on local codes, soil conditions, and other factors. This ensures that the grounding system is effective, safe, and compliant with all applicable regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including grounding and bonding requirements. Article 250 of the NEC covers grounding and bonding, providing specific rules for grounding electrode systems, equipment grounding, and bonding of metal parts. The NEC is updated every 3 years, and it is important to follow the latest edition to ensure that electrical installations are safe and compliant. Some key sections of the NEC that are relevant to mobile home grounding include Section 250.32, which covers grounding requirements for separate buildings or structures, and Section 250.50, which covers grounding electrode systems. These sections provide detailed requirements for the size and type of grounding electrodes, the size of grounding conductors, and the methods for connecting the grounding electrode to the electrical system. In addition to the NEC, local building codes may also have specific requirements for mobile home grounding. It is important to check with the local building department to determine the applicable codes and regulations. Local codes may be more stringent than the NEC in some cases, and it is important to comply with all applicable requirements. When installing a grounding system for a mobile home, it is important to use appropriate materials and techniques. Grounding electrodes should be made of corrosion-resistant materials such as copper or stainless steel. Grounding conductors should be sized appropriately for the size of the electrical system and should be protected from physical damage. Connections should be made using approved connectors and should be properly tightened to ensure a good electrical connection. It is also important to test the grounding system after installation to verify that it is effective. This can be done using a ground resistance meter, which measures the resistance between the grounding electrode and the earth. The resistance should be low enough to ensure that fault currents can quickly and safely return to the source. If the resistance is too high, it may be necessary to install additional grounding electrodes or to improve the connections to the existing grounding electrodes. Proper grounding and bonding are essential for electrical safety in mobile homes. By following the guidelines in the NEC and local building codes, and by using appropriate materials and techniques, it is possible to create a safe and effective grounding system that protects occupants from electrical shock and minimizes the risk of electrical fire. Consulting with a qualified electrician is always recommended to ensure that the grounding system is properly installed and meets all applicable requirements. In some cases, soil conditions may be unfavorable for grounding. For example, if the soil is very dry or rocky, it may be difficult to achieve a low resistance connection to the earth. In these cases, it may be necessary to use special grounding techniques such as installing multiple grounding electrodes or using a chemical ground rod. A chemical ground rod is a type of grounding electrode that contains chemicals that help to improve the conductivity of the soil. These ground rods can be effective in areas with poor soil conditions, but they must be installed and maintained properly to ensure that they function correctly. Lightning protection is another important consideration for mobile homes. Lightning strikes can cause significant damage to electrical systems and can even start fires. While bonding the frame to the power company's grounding electrode can provide some protection against lightning strikes, it is not a substitute for a complete lightning protection system. A complete lightning protection system typically includes lightning rods, surge suppressors, and grounding conductors. Lightning rods are installed on the roof of the mobile home and are designed to intercept lightning strikes. Surge suppressors are installed in the electrical panel and are designed to protect sensitive electronic equipment from voltage surges caused by lightning strikes. Grounding conductors connect the lightning rods and surge suppressors to the grounding electrode system. If a mobile home is located in an area with a high risk of lightning strikes, it is recommended to install a complete lightning protection system. This can significantly reduce the risk of damage from lightning strikes and can help to protect the occupants of the home. Regular inspection and maintenance of the electrical system are also important for ensuring electrical safety in mobile homes. The electrical system should be inspected at least once a year by a qualified electrician. The electrician should check for any signs of damage or wear, such as cracked or frayed wires, loose connections, or corroded components. Any problems should be repaired promptly to prevent electrical hazards. It is also important to test the ground fault circuit interrupters, or GFCIs, regularly. GFCIs are designed to protect against electrical shock by quickly interrupting the flow of electricity in the event of a ground fault. GFCI should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Overloaded circuits are another common electrical hazard in mobile homes. Overloaded circuits can cause wires to overheat, which can lead to fires. To prevent overloaded circuits, it is important to avoid plugging too many appliances into the same circuit. If a circuit breaker trips frequently, it is a sign that the circuit is overloaded. In this case, it may be necessary to move some of the appliances to a different circuit or to install an additional circuit. Extension cords should be used sparingly and should never be used as a permanent wiring solution. Extension cords can easily become damaged, which can create a fire hazard. If it is necessary to use an extension cord, it should be a heavy-duty cord that is rated for the amount of power that will be drawn from it. The cord should be placed in a location where it will not be damaged or tripped over. Aluminum wiring is another potential electrical hazard in mobile homes. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. However, aluminum wiring can become loose over time, which can create a fire hazard. If a mobile home has aluminum wiring, it should be inspected by a qualified electrician. The electrician can determine if the wiring is safe or if it needs to be replaced. There are several options for dealing with aluminum wiring. One option is to replace the aluminum wiring with copper wiring. This is the most expensive option, but it is also the most effective. Another option is to install special connectors that are designed to be used with aluminum wiring. These connectors help to prevent the aluminum wiring from becoming loose. A third option is to apply a special antioxidant paste to the aluminum wiring. This paste helps to prevent the aluminum wiring from corroding. By taking these precautions, it is possible to minimize the risk of electrical hazards in mobile homes with aluminum wiring. Electrical safety is a serious matter, and it is important to take all necessary precautions to protect against electrical shock and fire. By following the guidelines in the NEC and local building codes, and by consulting with a qualified electrician, it is possible to create a safe and effective electrical system for a mobile home. Always remember that electrical work can be dangerous, and it should only be performed by qualified professionals. Attempting to perform electrical work without the proper training and experience can be hazardous and can even be fatal. It is always best to err on the side of caution and to hire a qualified electrician to perform any electrical work in a mobile home. They will be able to identify potential hazards and to ensure that the electrical system is installed and maintained properly. Also, it is crucial to be aware of carbon monoxide. Carbon monoxide is a deadly, odorless, colorless gas. It is produced by the incomplete burning of fuels such as gasoline, propane, natural gas, and wood. Carbon monoxide can be produced by malfunctioning appliances such as furnaces, water heaters, and stoves. It can also be produced by running a gasoline-powered generator indoors. Carbon monoxide poisoning can cause a variety of symptoms, including headache, dizziness, nausea, vomiting, and loss of consciousness. In severe cases, carbon monoxide poisoning can be fatal. To protect against carbon monoxide poisoning, it is important to install carbon monoxide detectors in the mobile home. Carbon monoxide detectors should be installed on every level of the home and should be tested regularly. If a carbon monoxide detector alarms, it is important to evacuate the home immediately and to call the fire department or 911. Do not re-enter the home until it has been cleared by the fire department or a qualified technician. Never use a generator indoors or in an enclosed space. Generators produce carbon monoxide, and the fumes can quickly build up to dangerous levels. Make sure that all fuel-burning appliances are properly vented to the outside. The vents should be inspected regularly to ensure that they are not blocked or damaged. Have the furnace, water heater, and other fuel-burning appliances inspected annually by a qualified technician. The technician can identify any potential problems and can make any necessary repairs. Be aware of the symptoms of carbon monoxide poisoning. If experience any of these symptoms, evacuate the home immediately and seek medical attention. Electrical safety and carbon monoxide safety are both important considerations for mobile home owners. By taking the necessary precautions, it is possible to protect from electrical shock, fire, and carbon monoxide poisoning. Remember that safety is always the top priority, and it is always best to err on the side of caution. It is very important to remember also arc fault circuit interrupters. Arc fault circuit interrupters, or FSIs, are designed to protect against fires caused by electrical arcs. Electrical arcs can occur when wires become loose or damaged, or when appliances malfunction. These arcs can generate high levels of heat, which can ignite nearby combustible materials. FSIs are designed to detect these electrical arcs and to quickly interrupt the flow of electricity, preventing a fire. FSIs are typically installed in the electrical panel and are designed to protect the entire circuit. The National Electrical Code, or NEC, requires FSIs to be installed in all new homes and in many remodeled homes. The NEC also requires FSIs to be installed in certain locations, such as bedrooms, living rooms, and dining rooms. It is important to test FSIs regularly to ensure that they are functioning properly. FSIs should be tested monthly by pressing the test button on the device. If the FSI does not trip when the test button is pressed, it should be replaced immediately. Also remember tamper-resistant receptacles. Tamper-resistant receptacles are designed to prevent children from inserting objects into the electrical outlets. These receptacles have internal shutters that prevent objects from being inserted unless both prongs of a plug are inserted simultaneously. Tamper-resistant receptacles are required by the NEC in all new homes and in many remodeled homes. They are a simple and effective way to protect children from electrical shock. It is important to replace any standard receptacles with tamper-resistant receptacles if there are young children living in the home. In addition to size and tamper-resistant receptacles, there are several other safety devices that can be used to protect against electrical hazards. Surge protectors are designed to protect electronic equipment from voltage surges caused by lightning strikes or power outages. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by quickly interrupting the flow of electricity in the event of a ground fault. Smoke detectors are designed to detect smoke and to alert occupants to a fire. Carbon monoxide detectors are designed to detect carbon monoxide and to alert occupants to the presence of this deadly gas. By installing and maintaining these safety devices, it is possible to significantly reduce the risk of electrical hazards in a mobile home. Stay grounded and stay safe.